Okay, well the next bit of preliminary work to be able to deal with logs is the log rules. So again, if you do maths, you might feel really okay with this. You might just be able to skip this section. If you don't do maths or if you're not sure, then listen in and see, make sure that you kind of know what's going on here because they come in useful for using exponential functions. Well, the first log rule is this one, which says that the log of a times b is equal to the log of a plus the log of b. Well, what's actually going on there, and we'll see why it's useful later, but what's actually going on is, well, let's put in some numbers and by way of an example, rather than prove it, we'll just put in an example and see if it works. Well, let's say A was 100 and B was 1,000, for example. Then what this suggests is that the log of 100 times 1,000 should be equal to the log of 100 plus the log of 1,000. So is that true? Well, let's evaluate both sides and see if they are equal. Well, the left-hand side, log of 100 times log of 1,000, well, that's going to be the log of 100,000, because 100 times 1,000 is 100,000. And we can see that that is, well, the log of a number is what you have to raise 10 to get it. And so the log of 100,000 is 5, because 100,000 is 10 to the 5. Now let's look at the right-hand side. Well, the log of 100, well, you have to raise 10 to the power 2 to get the log of 100. And the log of 1,000 is 3, because 10 to the 3 is 1,000. So, well, sure enough, 2 plus 3 is 5. So we can see it kind of works, this rule, and it makes clear sense using that example why it must be true. But of course, this is true for any numbers, and for natural logs as well, which I'll come back to. The next rule is very, very similar, but it's just that the log of a divided by b is the log of a minus the log of b. And so, well, that is similarly intuitive, actually. Let's just do some numbers there. So we could say, well, the log of, let's say A was, let's say this time, A was 1,000 and B was 10. So the log of 1,000 divided by 10. And we can say, oh, well, according to this rule, that should be the log of 1,000 minus the log of 10. And to see that it works, we'll chuck some numbers in there. And, well, 1,000 divided by 10 is 100. So we've really got the log of 100 there, which we know is 2. And on the right-hand side, we've got the log of 1,000, which we know is 3, and minus 1, because the log of 10, what you have to raise 10 to get 10 is 1. And so we can see that that also checks out. We're good there. Everything's working, and it makes sense why that should therefore be a rule that we can rely on. And the last one, well, this time it says that the log of, let me move that digit out of the way because it's in the way, the log of a raised to the power b is equal to b log a. And so let's see why that should be true there. I'm just going to move that down a tiny little bit. Well, let's put some numbers in again. Let's do the same thing again as we did before. So this time we're going to say, okay, well, let's say the log of 100 squared, for example. So A is 100 and B is 2. Well, if this rule is correct, then that should be equal to 2 times the log of 100. And, well, 100 squared is 10 to the 4. So what I've got on the left-hand side is really the log of, 100 times 100 is 10,000, 10 to the 4. And on the right-hand side, I've got 2 times the log of 100, but we know the log of 100 is 2. But of course, the log of 10 to the 4 is what we have to raise 10 to get 10 to the 4, which is 4, and 4 equals 4. So that also works. So we've got, those are our 3 rules. And if you're, many of you may be very, very familiar with those, and there's no problem. If you're not sure, then hopefully that clears it up a little bit, what's going on with those. Well, of course, it's the same for the natural logs. So I'm just going to write down there, and these are the ones we're actually going to use right at this stage, that the natural log of a times b is the natural log of a plus the natural log of b. The natural log of a over b is natural log of a minus natural log of b, and the natural log of a to the b is b times the natural log of a. And, well, these are pretty useful when using exponential functions. So that's going to be what we're going to kick in with those in the next video.